Plevan with us. She's the TMDL program coordinator in the Watershed Division. And she's going to tell us this morning about TMDLs. What is a TMDL anyway? And she's going to answer all of our burning questions surrounding total maximum daily load studies and why we should care about them. Are they regulatory? And what are some of the main components of a TMDL report? Andrea collaborates with other MPCA staff and leadership across multiple divisions here at the MPCA, works with the EPA, and also works with outside consultants to determine TMDL priorities, oversee development and review of TMDL studies, and develop policy and guidance to balance TMDL needs of EPA, MPCA, and local partners. Andrea, hey, thanks so much for agreeing to come and tell us about TMDLs. The floor is yours as it is, and take it away.
Great. Thank you, Mark. Yeah, and thanks for inviting me and having me today. This is a talk that I first gave as part of the Minnesota Water Resources Conference in the fall, and I've adapted it and added some things to it. So hopefully you'll all learn something today. Okay, so what is a TMDL? So this is kind of a broad outline of my talk today. I'll go through what's a TMDL, talk a little bit about TMDLs as a planning tool, and then talk about what's next with TMDLs in Minnesota. And with that, I'll touch a little bit on both mercury and sulfate. So a TMDL is a specific type of water quality study that comes out of the Federal Clean Water Act. TMDL studies are done for waters that don't meet water quality standards. And technically, a TMDL is the amount of pollutant that a water body can assimilate and still meet water quality standards. We write up a numeric analysis as an equation. Pointer. So we have an equation that identifies the maximum amount of pollutant and then determines how much pollutant each source can contribute. So the TMDL is that maximum amount of pollutant. It's sometimes called the loading capacity. And then we divide it up into different sources, which include both non-permitted and permitted sources. So the LA, or the load allocation, allocates load to non-permitted sources. The waste load allocation allocates load to permitted sources. And then we also have a margin of safety that takes into account uncertainty in the data, in the analysis, and variability in the data set. TMDLs are one part of the state's watershed approach, and I'll talk more about that a little later. I want to highlight that the phrase TMDL can be confusing because it's used to describe both an equation that I just talked about and then the bigger study and resulting report. So this first part, what I just talked about, it's that equation. It's that TMDL, the load allocations, and the waste load allocations. But then a TMDL study also is this report. It includes identification of pollutant sources, noting where pollutant loads are high and where reducing a pollutant might be particularly beneficial, and then implementation strategies to reduce that pollutant. And so these analyses are done to support and complement that TMDL equation. We regularly monitor and assess our waters. Waters that don't meet water quality standards get listed as impaired on our impaired waters list, or it's called our 303D list of impaired waters. And we're then required by the Clean Water Act and EPA to develop TMDLs for impaired waters when that impairment is due to a pollutant. In terms of TMDL development, some entities that we work with at times can feel fatigued by the pace of TMDL development. It's a lot of work, but we need to keep in mind that once a water body is on that 303D list of impaired waters, we have to either develop a TMDL for it or otherwise remove it from the list of waters that need TMDLs. So we can prioritize TMDL development and defer TMDL development, but in the end, the ultimate goal is always to develop TMDLs for waters that need them. TMDLs are not regulatory on their own. They do not establish new regulatory controls. This is sometimes, people don't always understand this. Just because we say something in a TMDL doesn't mean that we are regulating that be. So NPDES permits. So NPDES is the National Pollutant Discharge Elimination System. So some NPDES permits reference TMDL wasteload allocations. And so although the TMDL itself isn't regulatory, it does have regulatory implications through the NPDES permit. So for example, per federal rule, wastewater effluent limits must be consistent with the assumptions and requirements of any wasteload allocation for that discharge. And then we have stormwater permits as well that reference TMDL wasteload allocations. But for non-permitted sources, there's no regulatory link between TMDLs and non-permitted sources. One benefit of TMDL studies is that they pull information together. So they identify primary pollutant sources, how to address the sources, and then an approximate level of effort needed to address the impairments. And this is sometimes referred to as the math and the path. This list here shows the different parts of a TMDL report. And in the green, I've translated it into more simple language. So we present water quality data, we discuss where the pollutants come from, we identify loading goals, and then we lay out an approximate path of how to get there. So the next few slides use the draft River Watershed TMDL report as an example to show some of the different parts of the TMDL study. And I say draft, but it's about to go to EPA for final approval. In this case, this is for Mill Creek. It's a creek with where the fish and the macroinvertebrates don't meet our water quality standards. And so we looked at water transparency data in the stream to get a sense of when is transparency the poorest, which is likely when the transparency is poor, that's when sediment in the stream is the highest. And so in this figure here, we have low flows moving to high flows on the right. And we saw the poorest transparency here under high flows. And so this suggests that sediment loading to the creek was highest under these high flow conditions. We look at land cover. We see that there's a high proportion of the watershed in row crops and other cultivated land. And then we do a source assessment for TMDLs. And the focus of a source assessment is where does each source come from and how is it delivered to surface waters? In this case, we used a watershed model to identify the primary sources of sediment. So those were cropland and pasture runoff, and then also in-channel sediment sources. And we use this information along with that water quality data assessment in the previous slide to conclude that it's sediment that primarily reaches the stream during watershed runoff events from agricultural lands and from channel erosion during high flows, that this is what's causing the impairment of the macroinvertebrate and the fish. So now back to the math and the path for a little bit. This is the math. It's an example of a TMDL equation, which ends up being a big table for many TMDLs. For the Mill Creek TMDL, so this TMDL was written for TSS, or total suspended solids, which is used to represent levels of sediment. So for this TMDL, TSS TMDL, we calculated the loading capacity, or the TMDL right here, for 5 different flow zones, and we then divided the allowable loads up according to source type. So you'll see some familiar phrases here that I mentioned, the waste load allocation, the load allocation, the margin of safety. I'm not going to go into the detail of the different sources here or how we came up with the numbers. So let's just say that these are the numbers that the EPA needs to approve a TMDL. What is often more applicable to local water managers is this pollutant percent reduction goal right down here, which in this case is 17%. And I like to look at this pollutant percent reduction goal as an indication of the level of effort needed to bring the water body back to meeting water quality standards. So it's not super precise. In this case, 17% is a modest amount of reduction needed. If the reduction were 85% or 95%, which we do see in many TMDLs, then that would suggest that much more aggressive measures are needed to restore the water body. So that was the math, and now this is the path, or the recommended implementation strategies, which address the primary sources and the reductions that were indicated by the math. So in the case of Mill Creek, we recommend to start with watershed practices to reduce total suspended solids and runoff from the headwaters drainage area and to reduce stream peak flow. And then we list strategies that can accomplish this. And then we also then recommend to follow up with in-channel practices after those watershed practices are complete. So given what we just saw about what is included in a TMDL report, with these TMDL components, a TMDL can provide the basis for how to move forward in watershed planning to address the impairment. So in Minnesota's overall watershed management framework, multiple state agencies and local partners are involved in different steps of water management, from monitoring and assessment, problem investigation, implementation planning, and then implementation itself. And TMDLs fall under these two boxes that I've highlighted here at the bottom: problem investigation and research, where we're analyzing data and determining the needed load reductions, and then restoration and protection strategy and development, where we're recommending management practices and other approaches to achieve the load reductions. Our RAPS reports, so RAPS reports are watershed restoration and protection strategy reports. These are also headed up by the watershed program, and these also fall into the step of the framework. And the RAPS reports are the link between the technical work that we do in TMDLs and other technical work, and then local water plans and subsequent implementation. So the information from TMDLs down here flows up through the framework. The TMDLs inform restoration strategies for the impaired waters in the RAPS. And then information from the RAPS is used to develop the local water plan, or the One Watershed, One Plan, by local partners. And then this then guides on the ground implementation of management practices. So a little information just about RAPS reports to show that link between TMDLs and the local water plans. Findings from TMDLs are incorporated into the RAPS, in addition to other technical work, to identify strategies to meet the TMDLs. And then RAPS also includes strategies to protect water bodies that aren't impaired. We often use our watershed models, modeling scenarios in HSPF to help target strategies. We not only address pollutant-based stressors, but also talk about non-pollutant stressors that were identified in our stressor identification reports. And then in some watersheds, there's a heavy emphasis on partner and public participation, where we're connecting with people who live in the watershed to discuss what implementation and protection strategies would work best. We have a 10-year cycle of doing the watershed approach on all of our major watersheds in the state, and we had a statutory deadline of June of last year, so just a little under a year ago, to complete the first cycle of RAPS and TMDLs, and we did meet that deadline. We're into the second cycle, which we started in about 2019, so we finished already 3 of them, and one is very close to being completed. And so this is where our second cycle is where we're revisiting each of the watersheds and doing TMDLs where needed and doing a RAPS update report. So getting back to the Mill Creek example to show how the TMDL information flows up through that water management framework. Mill Creek is identified in the Root River Watershed RAPS report as a priority area for implementation. And the RAPS incorporates the total suspended solids load reduction strategies, so over here, and goals from the TMDL report. So this gets put into the RAPS, and then local implementation of the One Watershed, One Plan, and this watershed is targeting these types of cost share projects in the Mill Creek watershed. So I'm now going to switch over to the TMDL team and what we're up to these days. We have 3 TMDL writers. I'm one of them, and the 3 of us, we each are TMDL writers and have one kind of another part of our job. So I'm the TMDL program coordinator. Katie Taylor is a TMDL writer and our waterborne pathogen expert, and Jeff Strom is our TMDL writer and lakes eutrophication expert. And we are in the watershed analysis and modeling unit in the watershed division in the south section. Watershed analysis and modeling unit, more affectionately known as WAM. We have TMDL liaisons in the municipal division. So Anna Bush is our stormwater TMDL liaison and Marco Graziani is our wastewater TMDL liaison. And they both represent their respective programs to make sure that TMDLs include the appropriate information, adequate information to inform the permits and the extent of work needed for permittees to meet their wastewater allocations. Emily Zanone is our new water quality trading coordinator, also in the municipal division. Water quality trading is a market-based approach to reducing pollutant loads to water bodies. And so she'll be working in all things water quality trading as she works out what this new position will be. And then we also work very closely with our watershed modeling staff that are in our unit. They develop and calibrate watershed models for use in our TMDL and RAPS work, in addition to wastewater permitting. Carrie Freeman is our liaison, and so she's helping to coordinate and communicate between the TMDL writers and the watershed modelers. We don't have a designated liaison with feedlot staff, but we do work with feedlot staff and supervisors as well. So just to build on that last slide, the TMDL program links with several other programs in the agency. EAO heads up the monitoring, assessment, and impaired waters list development. And so we have a lot of interaction with EAO through the RAPS process for individual major watersheds, and then on a statewide scale with the impaired waters list, which is updated every 2 years. I mentioned earlier that link between wastewater and stormwater permits with TMDL wastewater allocations. So, right, I mentioned wastewater already. Stormwater also has that link. For stormwater, permittees that have wastewater allocations for E. coli bacteria, chloride, and temperature TMDLs have a list of best management practices that they have to do per their permit conditions. For other types of impairments, mostly phosphorus and sediment, the permittees need to show that they're achieving the wastewater allocation, or need to show how they will achieve the actual numeric wastewater allocation or percent reduction in the TMDL. So for these pollutants here, it's a more numeric based accounting of whether or not they're complying with their wastewater allocation. Right, we also work with feedlot staff in some projects to identify potential sources of pollutants or implementation strategies that are appropriate for the watershed and the situation. Air emissions, this is a little bit of a new frontier for us, that intersection between the air and water programs in TMDLs. And this mostly relates to mercury TMDLs, in that the primary source of mercury to water bodies is from atmospheric deposition, and the mercury air emissions from sources across the state and throughout the globe impact atmospheric deposition in our state. So where has the TMDL program been and what's next? So in the early years of TMDL development in Minnesota, we developed TMDL reports and implementation plans for individual water bodies or for small groups of water bodies. And then in 2008, with the passing of the Legacy Amendment and the creation of the Clean Water Fund, we shifted to a watershed approach. We've been developing TMDLs for many water bodies in a major watershed at a time. Then we are able to greatly increase that pace of TMDL development in these years. We also had many consultants working on TMDLs at the time, which also allowed us to produce many TMDLs. In the last few years, as we've started the RAPS updates, in which we're revisiting a watershed and completing new TMDLs and updating the RAPS reports, we're slowing down the pace of TMDL development. So when we start the RAPS update in a watershed, we work with local partners and other agencies to identify priorities for the RAPS updates. And in terms of TMDL development, this means that we won't necessarily develop TMDLs for all of the remaining impaired waters, but rather we'll select a subset of the impairments for TMDL development. So we're being more deliberate at TMDL development, and we want to provide what the local partner needs in addition to what the state needs for the RAPS updates. We do need to keep in mind that we're still required to write TMDLs for all impaired water bodies, but we can prioritize which TMDLs to write first. So speaking of prioritization, we have our Minnesota TMDL prioritization framework for the next 10 years. And this is a planning framework that describes long-term priorities, a rationale for selecting these priorities, and a general strategy for implementing the goals of EPA's framework. So EPA, it's called the EPA Vision. It's their Vision for the Clean Water Act Section 303D program. And they have this, it's the second vision that they've published for the 303D program, and it's a 10-year framework, and they require states to provide their own framework to say how they're going to meet EPA's vision for the 303D program. So we just submitted our TMDL prioritization framework to EPA this month to address that, the updated vision. And in our framework, we describe how the watershed approach helps to prioritize which TMDLs to work on. So when we start the new RAP cycle, we're working with PCA programs and with local partners to determine the priority impairments to address with TMDLs. And then we also have other strategies and initiatives that inform our priority framework. We have other efforts that influence how we decide which TMDLs to develop. So we have the nutrient reduction strategy, we have environmental justice and climate change, and then we have pollutants, mercury, PFAS, sulfate, and chloride. And I mentioned these pollutants. That doesn't mean that we're writing TMDLs for all of these impairment types, but rather that we have programs in place across the agency around these pollutants, and that those programs are informing whether we identify these pollutants as priorities for TMDL development. To go along with the prioritization framework, so the prioritization framework covers a 10-year period, but every 2 years we need to send to EPA a list of TMDLs that we commit to working on in the 2-year time period. And so we also just submitted this TMDL commitment list. We have 2 types of impairments on this commitment list for the next 2 years. It covers federal fiscal year 25 through 26. So that time period actually will start in September of this year and then go for 2 years. We are currently working on 73 TMDLs impairments in the St. Louis River Watershed Mercury TMDL project, which I'll talk more about later. So I won't go into detail right now. And then we have this set here of our TMDLs that we're developing through the watershed approach. So these are the major watersheds highlighted in the map. This is where we're actively either are or will be working on TMDLs in the next 2 years. And these are the impairments that we've committed to working on in the next 2 years. And you'll see the number of impairments is relatively small, especially compared to the 73 up here. This number of impairments just means that these are the numbers that we're committing to. It doesn't mean we can't do more. So in many cases, we actually will be developing more TMDLs because of the way that we work with local partners to determine priorities, where these were the ones here in this list that we could commit to at this time, but we will likely have more TMDLs in development during this 2-year time period. So other things that are ongoing and coming up, we have other initiatives underway that will help inform TMDL development and local water planning. One project is investigating E. coli sources across the state. Will be able to be used in watershed planning efforts, including TMDLs and RAPs and One Watershed, One Plans, and to inform management decisions. And this project is headed up by Katie Taylor, a waterborne pathogens expert. And then another project is looking at what factors drive lake delisting so that we can better understand the link between management and lake water quality improvement. And this project is headed up by Jeff Strom, our lake and eutrophication expert. We're also often asked about TMDL updates or revisions. We know that things change on the landscape. Water quality conditions change. Watershed disturbances and management actions change what's happening on the landscape, and permits change. Sometimes we just learn more about what's always been there. So because of all this, pollutant load reduction needs change. To accommodate this change in our growing understanding of water quality conditions, we build adaptive management into all of our TMDL reports. With adaptive management, water bodies are monitored and local partners shift the restoration approach as needed and without TMDL revisions. This is, watershed management progressing as normal. In some cases, we might need formal TMDL revisions, and we're prioritizing TMDL divisions if there are permitting implications. So, for example, we're revising a lake phosphorus TMDL that left out part of a city from the watershed boundary. So this is The example is the impaired lake, and the purple here is the corrected watershed boundary. And what happened was in the approved TMDL, there was not this whole part, but parts of this highlighted area here were not accounted for as being in the watershed boundary and draining to the lake. And the city needs to document, the city has been implementing best management practices in this area, and they need to document that this area is within the lake watershed so that they can account for the load reduction practices that they implemented in that area to show compliance with their waste load allocation. So we updated the TMDL and the allocations to account for these changes. We have a lot of impairments that still need TMDLs, and we haven't determined the approach for all of them. So in this graph, the teal areas on the top of the bar show the number of impairments that either need TMDLs or we don't yet know if they need TMDLs. And what stands out here are the bioassessment impairments. 92% of the 2,000 or so impairments still either need TMDLs or we don't yet know. With dissolved oxygen over here, although we have far fewer impairments, almost 75% of the dissolved oxygen impairments are in the same boat, where we either need a TMDL or we don't yet know. And so for these types of impairments, the bioassessment and the dissolved oxygen, we don't yet know on many of them because we first need to identify what's causing the impairment and whether the cause of impairment is a pollutant like sediment or nutrients, or if the cause is something else such as poor habitat. We do this through the stressor identification process for bioassessment impairments, and we write TMDLs for the pollutant-based causes, and then we don't write TMDLs for other causes. For example, for a bioassessment impairment, it might be that high suspended sediment is causing the bio impairment, and we can write a TMDL on that. Or maybe it's due to habitat or alteration or other non-pollutant causes, and we wouldn't write a TMDL on that. We would instead recategorize it in our impaired waters list. So then moving on to other impairment types, we frequently write TMDLs for E. coli and nutrients and TSS. These are kind of our bread and butter TMDLs, and these are the impairments that our local partners are typically interested in. And so we're continuing with these TMDLs across the state. Another bar that stands out represents the mercury impairments. We have a statewide mercury TMDL, which was approved in 2007. And this TMDL addresses about 75% of the mercury impairments across the state. And the remaining mercury impairments still need a TMDL. And I'll talk next about a mercury TMDL project in development. We also have PFAS and sulfate impairments, although there are relatively lower numbers of these impairment types. They involve pollutants that the public has a lot of interest in. We have not yet developed TMDLs for these pollutants, and we're still considering how to address them. And I'll talk about sulfate a little bit more coming up. So I will move on now to mercury and sulfate, and then I will wrap up the talk. So I mentioned the statewide mercury TMDL. So this map here, the light blue water bodies are impairments that were addressed by the statewide mercury TMDL. So they do not need a TMDL, a mercury TMDL, they're done. The darker impairments, the reddish, burgundy-ish impairments, are those that need reductions beyond those that are called for in the statewide TMDL to meet mercury standards. So the concentration of mercury in fish is higher than kind of the average across the state. And so we need to call for additional mercury reductions. Many of these remaining impairments are in the St. Louis River watershed, which is up here. And so this TMDL project has been in progress for a few years. It's the first mercury TMDL being done in the state that goes beyond the statewide TMDL. So it's the first watershed-based mercury TMDL in the state. And so we're starting with the St. Louis River watershed with the idea to develop an approach to TMDLs for these impairments, and then take what we've learned from this study and apply it to other impairments across the state, other mercury impairments. So this is the St. Louis River watershed up closer. So it includes the two major watersheds, the St. Louis River watershed and the Cloquet River watershed, which is tributary to the St. Louis River. Interest from the statewide TMDL implementation committee and other interested partners and parties has helped the decision to start in this watershed. And the St. Louis River watershed stands out in having a lot of the factors that can influence mercury transport and mercury methylation. So mercury methylation is the process that converts mercury into its more toxic form. So these factors that can influence mercury transport and methylation, we have organic carbon and low oxygen conditions, which are really common in wetlands, and we have a lot of wetlands in these watersheds. And we also have elevated sulfate levels in the region, which can influence mercury methylation. So there's a lot of partners and stakeholders and interest groups that are interested in the topic. We have the Fond du Lac Reservation borders the St. Louis River and they have subsistence. The band members have subsistence fishing rights throughout much of the watershed per the 1854 treaty. We have the Mesabi Iron Range in the northern part of the watershed, and this industry represents many of the point sources. Environmental groups have shown a lot of interest in the project, and so there's been a bigger public outreach component of this TMDL project compared to the typical TMDL. And the project has been a collaboration between EAO and Watershed. So Jenny Brentrup from EAO is heading up the mercury science part of the project, and I'm heading up the TMDL part of the project. And then we have we have lots of support from other staff and leadership from both divisions. And the project is focusing on transformations and transport of mercury. So mercury, as I mentioned, it typically enters the environment from the atmosphere. After it reaches the land and the surface waters, mercury can then become methylated, in which microorganisms convert mercury into methylmercury, which is the form that builds up in fish and is toxic to humans who eat the fish. So we know that the primary source of mercury is from atmospheric deposition, and that was the focus of the statewide TMDL. The new piece that we've added to this project is that we're looking at where is the mercury more likely to be methylated, so that's the transformation piece. And then where is it more likely to reach surface waters? That's the transport piece. So atmospheric deposition being the primary source of mercury, so it can enter the watershed directly through surface waters, and then it can also enter the watershed by being deposited on land and then reaching surface waters through watershed runoff. And some land cover types carry more mercury into surface waters and could be mercury methylation hotspots. And so part of our technical approach is looking at these different land cover types to see if there are practices that we can do on the landscape to reduce mercury transport and transformation. So a rough project timeline, we've been working on it for a few years. We're working this year on finishing up the technical work and a draft report so that we can next year have different both internal and external review processes happening. We'll be continuing our public outreach, meeting with permittees and interest groups, and then with the aim of public notice in 2026, and then if all goes well, approval later that year or in 27. So I just wanted to talk about one more topic, which is sulfate impairments. We have approximately 2,400 water bodies in the state that are designated as waters used for the production of wild rice. Sulfate negatively impacts wild rice, and the state has a 10 milligram per liter sulfate water quality standard for these waters. The first sulfate impairments were listed on our impaired waters list in 2020, and we are up to 56 sulfate impairments on the proposed 2024 impaired waters list. And this map here shows in blue the waters used for the production of wild rice, and the red water bodies are where we have sulfate impairments per the proposed 24 list. Where does the sulfate come from? So we have both non-point sources and point sources of sulfate. In the non-point source category, we have geologic sources, atmospheric deposition of sulfate, and there's sulfate in fertilizer and potentially other agricultural products. For point sources, wastewater effluent has sulfate in it. And these sources that I've mentioned already are sources that are statewide. They do vary across the different regions, but they do exist around the state. Under point sources, we also have mine seepage, which is focused in northeastern Minnesota, where we have water from tailings basins that gets to surface waters either through surface discharges from the tailings basins or through groundwater. And sulfur is in the geological deposits that are being mined, and then it's released to the environment when the landscape is disturbed for mining activities. So sulfate sources differ by region. We also have varying baseline sulfate concentrations around the state. I wanted to thank Emily Brault for these images. She did a lot of this data analysis last year. So we have a pretty clear spatial pattern of the baseline sulfate concentrations. We have low sulfate concentrations in the northeastern part of the state, well below the 10 milligram per liter water quality standard. And then in southern and western Minnesota, the concentrations vary quite a bit, but are generally well over the 10 milligram per liter water quality standard. And then there's this transitional zone in between. So we can look at how the concentrations vary across the state and then generalize to these three zones in the map on the right, where there are clear differences in baseline concentrations in the northeast versus the south and the west. So in addition to sources differing by region, we also have baseline concentrations that differ by region. So we can take these patterns into consideration to help us inform our plans to sulfate impairments, if, how, or when we're going to be developing sulfate TMDLs. So in northeastern Minnesota, we have low baseline concentrations in most of the loading from point sources. The signal from these point sources is pretty clear in the surface water concentrations, especially because the baseline concentrations are so low. In southern and western Minnesota, we have higher baseline concentrations and then a mix of point and non-point sources. So PCA does not anticipate developing sulfate TMDLs to address the designated wild rice impairments in the near future. And the reasons are different in northeastern Minnesota versus elsewhere in the state. In northeastern Minnesota, most of the sulfate loading is from permitted sources with limited non-point sources. And the permitted sources are mostly mining discharges, but also include wastewater treatment facilities. Background levels are quite low. And in general, TMDLs are helpful when we have either just non-point source or a mix of point and non-point source, where we establish pollutant loading goals for all types of sources and balance them out in order to meet the water quality standards. In that case, the waste load allocations for point source help inform permit limits, and the load allocations for non-point source help local water planners and managers. But if we just have point sources, we don't necessarily need TMDLs, because the permit limits are developed with or without a TMDL, and the end result is the same. So a study to set an effluent limit would be similar for permit reissuance versus a TMDL study. So we can achieve these point source load reductions through reissuing permits with effluent limits. In cases like this, where we have just point sources, a TMDL wouldn't offer much beyond the point source limits, which can be set and are set without a TMDL. In southern and western Minnesota, we have a mix of point and non-point sources. Some locations in southern Minnesota have high baseline sulfate, but healthy wild rice populations. And so these locations might be candidates for site-specific standards, in which case the target, the sulfate target might change. We also know less about anthropogenic sources. We have things like soil amendments in agricultural areas, pesticides and other chemicals, and we don't yet know if these sources are big enough to affect the high baseline sulfate concentration. So for now, we're holding off on TMDL development in this region as well, while we're working through the permitting process and until we can work out these issues more. And I just wanted to end with some TMDL resources. We have our watershed project management page on the LORAX with TMDL and RAPS and other guidance documents. And then we have an external web page with TMDL and RAPS guidance that has a lot of that information. And that's it.
Awesome. If you guys have questions, feel free to put them in the chat. Oh, it looks like we just had one. So do the TMDL liaisons review and help approve the TMDLs, or at what point are these folks integrating into reviews and writing process?
Yes, the TMDL liaisons review TMDLs through as part of the internal review process. And I'm trying to find the questions. Can I see that?
I don't think you can see them while you're presenting.
Oh, okay.
So we have a question from Scott. Is the St. Louis River TMDL only for HG, or are there plans to do one for sulfate as well?
Just for mercury right now.
You can also feel free to unmute and ask a question
Yeah,
if
I have a
anyone's feeling
question,
brave.
Andrea. Well, other people are thinking of their questions. So it sounds like you also consider atmospheric deposition into the TMDLs as well. And I'm just kind of wondering how you go about estimating that flux and that amount of a contaminant due to atmospheric deposition into the TMDL calculation.
Are you talking about mercury or other pollutants or just
And well, really any. I guess I was not aware that you considered atmospheric deposition,
Yeah.
and that was interesting to me. I'm just kind of wondering how you go about, determining how much that might be in terms of
Yeah.
the contaminant load.
Yeah, so we consider atmospheric depositions, as far as I know, for just phosphorus and mercury. There may be others, but so for phosphorus, we have kind of average rates of phosphorus loading in atmospheric deposition that are compiled from the literature and other published papers. And so we just use those rates that kind of vary across the state by ecoregion. And often the phosphorus loads are pretty small to lakes, where they might be bigger as if you have a lake with a big surface area and a relatively small watershed. And there's not much we can do about atmospheric deposition in the short term here. So some people get frustrated because it's a source that we can't do anything about, but we still want to account for it. With mercury, let's see, there's a lot of models and data that are being used to summarize. There's the National Atmospheric Deposition Program that has mercury data for both wet and dry deposition, and Fond du Lac Band also has been collecting mercury atmospheric deposition data locally. So we have these different sources that we use for the project.
All right, Paul Gardner has a question. Is it hard to explain to the public how TMDLs are a big deal? Do you have a handy way to describe their value other than we are permitting an allowable amount of a pollution?
Good question. A handy way. Well, I don't know, I like this math in the path phrase. It's a little catchy. So, right, the math is that allowable amount of pollution, but also we're providing information to help guide local and statewide, in some cases, implementation of water quality improvement, and providing that information to the local partners to help them make the decision of what steps to take next.
And then Bill Dunn, a lot of numbers in a TMDL. How are costs of implementation projects covered in TMDL or RAPs? Dollars are important numbers.
Yes, and we actually have a Minnesota statute that requires us to provide cost estimates for implementation in TMDL projects, and it's hard because we're not developing highly specific plans for all of these restoration projects. That's what, in most cases, the local partners are doing, and so we're coming up with pretty rough ranges of estimates, like what's there's some numbers like what's the average cost to reduce nutrient loading per animal unit on a feedlot or per feedlot or things like that. That's where we'll work with staff from other programs. So we're doing a lot of kind of big picture estimating and generalizing when we come up with those estimates, and we usually provide a big range, but we do have those estimates in every TMDL report.
All right. Jenny Brentrup asks, has a single TMDL been written to address multiple pollutants at once, i.e. Mill Creek addressed TSS, but implementation strategies could reduce nitrate as well?
Yes, good question. Yes, the answer is yes. So Mill Creek, and I don't remember the exact pollutants there. It might have been on one of my slides. If there are multiple impairments, we'll often write TMDLs for multiple impairments at once. And then we'll talk about, right, that these practices can reduce both pollutants, and often, you know, those are the ones that are prioritized, those practices that can reduce different types of pollutants all at once.
All right, Laura asks, once a water body is listed on the 303D impaired list, is there a countdown or timeline as to when a TMDL has to be written? In other words, is there an average amount of time it takes to draft or finalize a TMDL?
No, there's no timeline or necessarily an average amount of time. You know, at the 10, 15 years ago when we were developing TMDLs, we were trying to just like do TMDLs for all impaired waters in a watershed. And we've, you know, now being a little bit more focused. And so it's through that prioritization process where we have our prioritization framework, and then that 2-year TMDL commitment list, that's determining which ones we're working on. And so that means that there's not going to be an average length of time. If there's a lower priority TMDL, then that may then take longer to get there.
Sure. Scott asks, do you have a favorite TMDL? Also, how much does it typically cost to have a consultant develop a TMDL?
I've never been asked that. Oh, I don't know that I have a favorite TMDL. I'll have to say the Mercury TMDL right now is probably one of the more challenging projects I worked on, but also really exciting and interesting. So maybe I'll give that as my answer. How much does it take to have a consultant to develop a TMDL? I don't have an average number. I mean, when we group many projects together or many impairments together, just so like a range. So if we're doing a whole bunch of TMDLs in a watershed, a contract with a consultant might be like 80 or 90,000 or 150. I don't know. That's kind of a range. That's for a whole group of TMDLs. Depends on what kind of modeling they're doing, and it depends on, you know, how much kind of side analyses we're asking them to do.
All right, I'm not seeing any other questions. Anybody has something, wants to unmute or put it in the chat quick? Otherwise, I think we can wrap up a couple minutes early today. No one? All right. Well, thank you so much. Oh, Jenny snuck right in. Okay. In cycle 2, are you able to go back to a watershed to evaluate the effectiveness of a past TMDL?
Yeah, that, yes, sometimes. I think that depends on, I mean, if we have additional monitoring data, the local partners will often be doing that, or could be done through the RAPS process. That's often more in the hands of the local partners, I would say. But we do, you know, we are looking at that project I mentioned that Jeff Strom was working on, looking at lake delistings. You know, he's looking at past TMDLs and lakes that have been delisted, and what are the BMPs that were done, and like how did that achieve the loading goals. So that's been helpful to then try to understand better like which approaches are more effective than others for past TMDLs.
Okay. One last, a second final call for questions. Okay. Awesome. Thank you so much, Andrea. Oh my gosh, you guys, you're killing me here. Okay. Tom asks, do you have an automatic reminder to revisit TMDLs as part of the RAPS update? That's a great question.
Do you have an automatic reminder to revisit TMDLs as part of the RAPS update?
Or maybe is there like a time frame that they need to be
That's for
revisited
you to
in?
do, Tom. So as part of the RAPS update, project managers are kind of at the beginning of the next cycle, they're looking at all of the impairments in the watershed and what's been done in the watershed since then to figure out if a revisit, or maybe you mean like revisions. Often the revisions are when problems come up with permittees. And so our liaisons, our stormwater and wastewater liaisons know about these. And so they'll bring that up at the beginning of a REPS update to say, hey, there's been a problem. And so maybe we need to consider revising this TMDL.
I'm going to give an extra long pause this time. No additional questions? All right. And a third and deserved thank you to Andrea for a really super interesting talk today. We appreciate you taking the time to share about TMDLs with us.
Great, thanks. It was good to be here. Thanks, everybody.
Thanks, everyone.
Thanks. Bye.
Wonderful day.
Thank you.